Officer, Department of Electrical Engineering, Naval Institute of Technology. So today I'm going to discuss about the subject Power System 1. This is the lesson plan of the subject, and here is the outcome. There are total 3 outcomes for this particular subject. My topic of discussion today is economic aspects in power generation. So first, let's try to understand about the introduction of this topic. So here, the function of a power station is to deliver power to a large number of consumers. However, the power demands of different consumers vary according with their activity. The results of this variation in demand is that load on power station is never constant. Rather, it varies from time to time. The power demand by the consumers is supplied by the power station through the transmission and distribution network. A consumer's load demand changes. The power supply by the power station changes accordingly. So there is a concept, that is the base load and peak load. So let's try to understand what is base load. So it is the minimum level of electricity demand required over a period of 24 hours. That means the base load is the minimum level of electricity demand required over a period of 24 hours. It is needed to provide power to components that keep running at all times. So base load is basically the minimum level of electricity demand required over a period of 24 hours. Now the peak load. The peak load is time of high demand. These peaking demands are often for only shorter durations. In mathematical terms, peak demand could be understood as the difference between the base demand and the highest demand. Now, the example of household loads: microwave oven, toaster, and television are example of peak demand, whereas refrigerator and HVAC system are example of base demand. This constant power, which is required at all times, called the base loading. But during a special event like the final match of World Cup, the demand will be more. As a lot of people will watch TV, the short high demand period is considered to be the peak loading. So when the people is watching TV for a long time, like final match of World Cup football or World Cup cricket is running, and all the people are watching TV. On that time, the maximum demand will occur, and this type of demand is called the peak loading. Variable load and power station. So the load on a power station varies from time to time due to uncertain demands of the consumers, and is known as variable load on the station. The consumers require their small or large block of power in accordance with the demand of their activities. Thus, the load demand of one consumer at any time may be different from that of the other consumer. The result is that load on the power station varies from time to time. Effects of variable load. The variable load on a power station introduces many perplexities in its operation. Some of the important effects of variable loads on a power station are need of additional equipment, increases of production cost. So the next important part is the load curve, the very basic part. So the curve showing the variation of load on the power station with respect to time is known as a load curve. That means load variation with respect to time is called the load curve. That means if we divide 24 hours and the load is in megawatts, so you can find at midnight the load as per the figure which is given here, the minimum load at night 12, and then it will increase when it is morning 6 to 8, and then again decrease, and in this way the maximum demand at the evening time. So this we can represent the load demand like this, and this is basically the daily load curve. This type of curve is called the daily load curve. Load variations during the whole day, that means the 24 hours, are recorded half hourly or hourly and are plotted against time on the graph. The curve thus obtained is known as daily load curve, as it shows the variation of the load with respect to time during the day. The load curve, the monthly load curve can be obtained from the daily load curve of that month. For this purpose, average values of power over a month at different times of the day are calculated and then plotted on the graph. So normally you can find three types of load curves: commercial load curves, industrial load curves, and residential load curves. For different sectors, the load curve is calculated in different ways. So here I am going to discuss on the importance of the load curve. The ratio of the area under the load curve, the total area of rectangle in which it is contained, gives the load factor. So you have to remember about the definition of load factor. So the load factor is a ratio to average load to maximum demand. Here average load into 24 hours by maximum demand into 24 hours. So in this way we can represent the load factor. Now the load curve helps in selecting the size and number of the generating units. The load curve helps in preparing the operation schedule of the station. These are the importance of load curve. Now the important terms and factors. We have to remember connected load, cold reserve, hot reserve, spinning reserve, and farm power. Connected load is the sum of continuous rating of the load consuming apparatus connected to the system. Cold reserve with that reserve generating capacity which is available for the service but not in the operations. Hot reserve is that reserve generating capacity which is operation but not in service. Spinning reserve is that generating capacity which is connected to the bus and ready to take load. And the farm power is the power intended to be always available when under emergency conditions. So now the connected load. The connected load is basically the sum of the continuous rating of the load consuming apparatus connected to the system. So these are the important terms and factors. Now the power station supplies load to thousands of consumers, and each consumer has contained certain equipment installed in his premises. If a consumer has connections of 500-watt lamps and as an example we can represent like this, and a power point of 500 watts, then connected load of the consumer 5 into 500 plus 500, that is 1000 watt. The sum of the connected loads of all the consumers is the connected load to the power station. The sum of the connected load of all the consumers is the connected load to the power station. That means the consumer using the total amount of connected load of all the consumers is the connected load to the power station. Now the maximum demand. It is the greatest demand of the load on the power station during a given period. In the load curve example, the maximum demand on the power station during the day is 6 megawatt, and it occurs at 6 am. As per the load curve figure, we already find that the maximum demand is 6 pm. The maximum demand is generally less than the connected load because all the consumers do not switch on their connected load to the system at the time. Knowledge of maximum demand is very important as it helps in determining. So we have to remember all the time that the maximum demand is generally less than the connected load. Third point is the installed capacity of the station. The station must be capable of meeting the maximum demand. Now we're going to talk about the demand factor. It is the ratio of maximum demand on the power station to its connected load. So demand factor is equals to maximum demand by connected load. The value of demand factor is usually less than 1. It is expected because maximum demand on the power station is generally less than connected load. If the maximum demand on the power station, as an example, we can say that if a maximum demand on the power station is 80 megawatt and the connected load is 100 megawatt, then the demand factor is maximum demand by connected load, that is 80 by 100, that means it is 0.8. The knowledge of demand factor is vital in determining the capacity of the plant equipment. The next important terms and factor, average load. The average of loads occurring on the power station in a given period is known as average load or average demand. So daily average load equals to number of units generated in a day divided by 24 hours, and monthly average load will be number of units generated in per month divided by number of hours in a month. If we try to find the yearly average load, then it should be number of units generated in a year divided by 8760 hours, the total hour in a year. So for that we can say that the average load, the average of loads occurring on the power station in a given period is known as the average load or average demand. Another important terms and factor, load factor equals to average load by maximum demand. So in the plant, is it operation for T hours, the load factor equals to average load into T by maximum demand into T equals to units generated in T hours by maximum demand into T hours. The load factor may be daily load factor, monthly load factor, or annual load factor if the time period considered is a day or a month or a year. Load factor is always less than 1 because average load is smaller than the maximum demand. And the last point is the load factor always key role in determining the overall cost per unit generated. Higher the load factor of the power station, lesser will be the cost per unit generated. This is the important factor we have to consider. We have to remember that the higher the load factor of the power station, lesser will be the cost per unit generated. Now it is diversity factor. Diversity factor is a ratio of sum of the individual maximum demand divided by maximum demand on the power station. So we can define like the ratio of the sum of individual maximum demand to the maximum demand on power station is known as the diversity factor. A power station supplies load to various type of consumers whose maximum demand generally do not occur at the same time. Therefore, the maximum demand on the power station is always less than the sum of individual maximum demand on the consumers. Obviously, diversity factor will always be greater than 1. And finally, we can say that the greater the diversity factor, the lesser is cost of generation of power. So, diversity factor is also playing a very important role for the power economics, generation economics. Next, plant capacity factor. Plant capacity factor is equals to the actual energy produced by maximum energy that could have been produced. So it is the ratio of actual energy produced to the maximum possible energy that could have produced during a period. So plant capacity factor equals to actual energy produced divided by maximum energy that could have been produced. So you can say that is equals to the average demand into T divided by the plant capacity into T. So average demand divided by plant capacity. So the value or the definition, it is ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. Thus, if the considered period is 1 year, we can say that the plant capacity factor is annual kilowatt hour output divided by plant capacity into 8760. The plant capacity factor is an indication of the reserve capacity of the plant. A power station is so designed that it has some reserve capacity for meeting the increased load demand in future. Therefore, the installed capacity of the plant is always somewhat greater than that of the demand of the plant. So in this way, we can define the plant capacity factor. Now it is plant use factor. So plant use factor is the ratio between the station output in kilowatt hour divided by plant capacity into hours of use, that how many time it is used. So it is the ratio of kilowatt hour generated to the produced of the plant capacity and the number of hours for which the plant was in operation. So the most important part here that it is actually coming from the ratio of kilowatt generated and the number of hours of plant for which the plant was in operation. Suppose, as per example, we can say that suppose a plant having installed capacity of 20 megawatt produces annual output of 7.35 into 10 to the power 6 kilowatt hour and remains in operation for 2190 hours in a year. Then plant use factor will be equals to 7.35 into 10 to the power 6 divided by 20 into 10 to the power 3 into 2190 equals to 16.7%. Now it is load duration curve. So when the load elements of a load curve are arranged in the order of descending magnitude, the curve thus obtained is called a load duration curve. So here the load duration curves are given. So we have to remember that when the load elements of a load curve are arranged in order of descending magnitudes, the load curve thus obtained is called a load duration curve. Now if we consider example, suppose time in hours, morning 6 to 8, 8 to 11, 11 to 16, 16 to 19, 9 to 22, 22 to 24, 24 to 6. If the load is 20 megawatt, 40 megawatt, 50, 35, 70, 40 and 20, draw the load curve and load duration curve and determine the load factor from the curve. So if it is the example, so we can find the unit generated per day equals to area under the load curve. So 10 to the power 3 into 20 into 8 plus 40 into 3 plus 50 into 5 plus 35 into 3 plus 70 into 3 into 40 into 2. So in this way we can find, look, so for the first one it is 20 into 8, then 40 into 3, that is we are multiplying the megawatt with time, then 50 into 5, 11 to 16, 5, 35 into 3, 70 into 3, 40 into 2, so 10 to the 6 into, so in this way calculating the whole value, we find 925 and 10 to the 3 kilowatt hours. So average load will be, this is a 24 hour span, so 925 and 10 to the 3 divided by 24, so the value will be 38,541 into 7.7 kilowatts. So load factor will be equals to 3854 1.7 divided by 17 into 10 to the 3. So the value is 0.55. The load factor, in this way we can find the load factor of the station. So here this is the load curve. So as a reference I take help from the principle of power system by BK Mehta and Rohit Mehta. And thank you all for watching the video.